This is Mr. Precella, and today we're going to be working on a review sheet for my third test in my face-to-face college algebra class. And let's see, how does this begin? Problem 1. If the following defines a one-to-one function, find its inverse. If not, write not one-to-one. Well, let's see. One-to-one means no repeated y values. No repeated y values. Now to find the inverse, you switch the x and y. So it's saying if there are no repeated y values, then switch or reverse the x and y's. So let's see, looking at this one, none of the y values are repeated, 4, 14, negative 12, 23. So just go through switching the x and y's. If you switch the x and y, we'd have 4, negative 10, 14, negative 12, negative 12, positive 12, and 23, negative 17. So let's see, which one is that? A, B, it's C, or D? They sure all look alike at first glance. D. Now notice this option for not one-to-one. That's what you would choose if there were repeated y values. Like on problem 2, the number 9, that's repeated y's. And so for that one, you don't go through and switch the ordered pairs. You only switch or reverse the ordered pairs if it's one-to-one. So if there are no repeated y values, switch the ordered pairs. Otherwise, write not one-to-one. So the answer there is C. A lot of times, students will choose, let's say, this answer, where they switch the ordered pairs, but you only switch the ordered pairs if it's one-to-one. Now, on problem 3, same instructions. It says if f is one-to-one, find an equation for the inverse. Well, when we have equations, functions written as equations or as formulas like these, then in order to decide if it's one-to-one, we said if there are even exponents, not one-to-one. Neither of these problems, 3 or 4, have even exponents, and therefore they are one-to-one. So how do we find the inverse? Let me get them over here to the sheet of paper. How do we find the inverse? How to find an equation for f inverse? Well, first of all, write using x and y. In other words, replace the f of x with the y. Switch x and y. Solve for y. And once you've solved for y, that's usually the lengthy step. Replace y with f inverse. So, on problem number 3, I'm writing down problem 3, f of x equals x cubed minus 7. No, 6x cubed minus 7. Well, first of all, I should have it written with just x's and y's. Instead of the f of x, just write it with the y. That's step 1. Now switch the x and y. I'll do that in blue. Switching the x and y, we'd have x equals 6y cubed minus 7. And now we're going to solve for y. how would I go about solving this thing for y? Well, I will do that. So solving for y. If I want to get this y by itself, I need to move the 7 over by adding 7. And then I would need to divide by 6. I'm trying to solve for y, or isolate the y. And then what cancels out a cube? Well, a cube root. So here's what I have. Y equals the cube root of x plus 7 all over 6. And once you have the y by itself, what's remaining is the inverse. So I'm not going to bother replacing y with f inverse. That's how it's written here on the, let's see, review sheet. I'm looking for the one that says x, the cube root of x plus 7 all over 6. That looks like B. Okay. Now, problem number 4. Follow the same steps. Write the equation using x and y. Switch x and y. So here's number 4. I'm just going to do it right out beside it here. So problem number 4. F of x equals 9 over x plus 8. I'm going to go ahead and skip straight to the first step. Write it with a y. Y equals 9 over x plus 8. Switch x and y, solve for y. So switching the x and y, I have x equals 9 over y plus 8. And I'm going to go ahead and think of this as x over 1 and cross multiply. xy plus 8x equals 9. And now go about getting this y by itself. How would I isolate the y? Well, I'll move the 8x over. So you could write 9 minus 8x, or I'm going to write negative 8x plus 9, so you don't decide to subtract the 9 and the 8. And then divide by x, and the y is by itself. So that is our equation for the inverse. Okay. So let's see, which one is it? Negative 8x. Is it C? I'm thinking it's C. There. Now, so that was 1-to-1 and inverse functions. Next, we're going to start solving some equations where the variable is in the exponent. Notice those are called exponential equations. And problem number 4. Let me write it down. I'm writing down number 4. Oh, no, number 5. 4 to the 9 plus 3x power equals 1 over 256. Well, the most basic way to solve an equation that has the variable in the exponent is to write both sides with the same base. The big numbers base, the small stuff exponents. So my first thought is to look at the right hand side and ask myself, okay, can I write all of this with a big 4? And I think I can. How many 4s would I need to multiply together? I'm starting with the 256. How many 4s would I need to multiply together to get 256? Well, let's see. 4 times 4 is 16, times a third 4 is 64, times a fourth 4 is 256. So you might want to use a calculator to convince yourself. 4 to the fourth is 256. But wait a minute. I don't just have 256. I have 1 over. And so, in order to write it without that 1 over, I would make that exponent negative. Remember our definition for a negative exponent. We said a to the negative n power means 1 over a to the positive n power. So when you see it written like this, 1 over 4 to the fourth is 4 to the negative fourth. So now we have both sides with the same base. Now, significant thing about this is once you have the same base on both sides, the bases are the same. The only way these can be equal is if the exponents were the same. So just set 9 plus 3x equal to negative 4 and solve that for x. How would I isolate the x? Well, I would subtract 9, negative 4 minus 9, negative 13, then divide by 3. So negative 13 over 3, that's answer D. Now for the next one. The next one has a lowercase e in it. And we said that e is a decimal number, Euler's number 2.718281828 approximately. So the nice thing about the problems that have e in it is if e is in the problem, then that's the common base. You have to look and try to figure out what the common base is. So just write both sides e equals e without any parentheses. Well, to raise one power to another, we have that exponent rule. A to the m raised to the n is a to the m times n. So we have e to the 5x minus 1 equals e to the 4 times negative x is not 4 minus x, it's negative 4x. Bases are the same, so the exponents have to be equal. Isolate the x. How do I want to go about that? I think I'll move this over here and move the 1 over. 5x plus 4x would be 9x equals 1. Divide both sides by 9. 1 over 9 is the answer. So that would be answer choice A. Now let's see. The next one we're doing is problem number 17. And the common base isn't so obvious. Every now and then students will say, oh, right, 32 is 16 squared. No, no, no. 32 is not 16 squared. 16 squared would be 256. So, we write this like this. Problem number 7. 16 to the x minus 2 equals 32 to the 4x. Well, here's my thought process. I think to myself, could I rewrite 32 as 16 to a power? And of course not. Okay. Well, I could write 16 as 4 squared, but could I rewrite 32 as 4 to a power? No. So we're going to have to go smaller. 2. How many 4s would I need to multiply together to get a 16? Well, 2 to the 4th would give me 16. And if we're going to be able to do this one, we better be able to rewrite 32 as 2 to the power, and we can. 2 to the 5th. If you're in doubt, multiply it out to get, in your head or use a calculator. Convince yourself that 2 to the 5th is 32. Now we have one power raised to another, so you multiply those exponents. Be careful when multiplying, you distribute over addition or subtraction. So this will be 4x minus 8. Over here, just 20x. No distributing there. Well, the bases are equal, so the exponents have to be equal. Isolate the x. I think I'm going to subtract 4x. So I have 16x on the right and negative 8 on the left. Divide both sides by 16 to get a negative 1 over 2. And that is answer choice B. Okay. Problem 8 and 9 both have radicals in them, so let's make sure we remember the definition of a fractional exponent. Let's see. A to the 1/2 power is the same thing as a square root. A 1/2 exponent means square root. A 1/3 exponent would be a cube root, a 1/4 exponent, a 4th root, and so forth. It goes on and on forever. You would write it like this. A 1 over n exponent is an nth root. Those are the statements we're going to use to do problem 8 and 9. So when you look at it written like this, it's saying if you have a square root and you want to write it without the square root, write a 1/2 exponent. If there's a cube root, a 1/3 exponent. If there's a 4th root, a 1/4 exponent. Now, let me write down number 8. It says the square root of 7 raised to the x plus 4 power equals 49 to the x. Well, it's not too hard to figure out that the only way we're going to rewrite 49 is something to power is going to be 7 squared. Okay, so we could rewrite that 49 as 7 squared. But over here, we need to write this with just a 7 and an exponent, not that square root. Well, that's where this statement comes into play. A green square root can be rewritten as a green 1/2 exponent. Okay. And once you have it written like that, it's the same type of problem. Don't let the fact that there's a fraction there scare you too much. Same type as over here. Number, power raised to a power. Instead of distributing like I did up here, I think what I'm going to do, it'll make solving it a little bit easier. Because of this fraction, I'm just going to write this equals that. What do I mean? I'm writing it like this. 1/2 times x plus 4 equals 2 times x. To solve this for x, I think it's easier, oh, pardon me, to get rid of the fraction first. Let's see. I can multiply both sides by a green 2, and at that point I no longer have any fractions. On the left, all I have left is an x plus 4, and on the right I have a 4x. How would I isolate the x now? Well, subtract 1x, so 4x minus 1x, 3x equals 4. Divide by 3. We're getting 4 over 3. So what is that? That is B. Any questions there? Now, number 9 is the first problem on here using logarithms, and we had said that an important property of logarithms is this one: log base b of b to the w. If you have the same base here and here, the same small number, subscript and big number base, all of that cancels each other out, leaving you whatever that exponent is. And that's how I'm going to do number 9. Okay? Problem number 9. X equals log base 4 of the 4th root of 16. Well, here are my thoughts about this problem. If I could rewrite it with the same small number and big number right here, all of that would cancel each other out. So, it says solve an equation, so I know my answer is going to be x equals number. It might be a fraction. So, let's see. How would I write 16 with a big base of 4? I'm rewriting this 16 with this number. Well, that would be 4 squared. But we also have that 4th root. Okay? So a 4th root is the same thing as a 1/4 exponent. Whatever the root is, that's what goes in the exponent down here. So, excuse me, in the denominator here. Cube root, notice where 3 goes. So I'm going to go ahead and write this as 4 squared all over 4. This green 4 is that 4th root. If you wanted to do something like this, write it as 4 squared to the 1/4 and then multiply. You'll still get the same thing, but I went straight to this. The exponent, the power is on top, the root is on the bottom. Now the significant thing about that is now you have the same number here and here. All of that cancels out. And we have x equals 2 over 4, which we're not going to leave as 2 over 4. We'll reduce that to 1 over 2. So x equals 1/2. That is answer choice D. Now, I think I'll take a little break and then continue with this. So thanks for watching. We'll pick back up in a little bit.